right, so this is an extension of what we were doing with limit definition of derivative. This is 3.1b, goes with this homework worksheet that you already have, where you start off the front page just practicing the stuff we did on 3.1a, and the back is the new stuff. It is not really new, it is just an extension, so our first steps will be the same, that whole limit definition. But we're going to take what we did yesterday one small step further and use our derivative that we find as an answer to find the equation of a tangent line. For example, a very typical problem would be find the equation of a tangent line if the f of x is x squared minus 3x, that's pictured over here, and I want to find the equation of a tangent line that goes through the point 2, -2. So if you look at it, remember how we said like the slope is really steep here, negative, less steep, more shallow, and then starts going positive, and then really steep, positive. If I could pick any point. Remember, derivative finds the slope at any point on this line. If I pick this one and just like eyeball it, a tangent line is a line that just touches that graph one place. So this purple line I just drew is the tangent line I want to find the equation for. Well, what do you need in order to find a tangent line? Well, what do you need for any line? You need a slope and a point. Your slope and an intercept, but guess what? I already got a point. All I need is slope at that place. I wonder what I could use to find slope at any point. How about the derivative? Because the derivative finds slopes at any point. So I can find the slope at that point if I use the derivative. So I got to find the derivative of this. That's what's kind of sneaky. The equations nowhere in here say find the derivative, but you have to know tangent line is a line, and a line needs a slope and a point. Slope is found using derivatives. Can't say that enough. Slope is found using derivatives. All right, so let's do this. The limit, this is good practice from yesterday. The limit as delta x goes to 0 of f of x plus delta x. This is the limit definition of derivative. It finds the instantaneous slope at any point. So now, let's get used to it. I hope you're getting pretty good at this. You got to do those practice problems, though. If I plug in an x plus delta x, it's x plus delta x squared minus 3 times x plus delta x. That was this part. And then I have a minus sign between them. And then this part is just to rewrite with parentheses. Don't rookie that up or stuff won't cancel later. Over delta x. So pause for a second, make sure you're cool with that. X plus delta x is just filling in here as if it were a number. If it was a number 8, I would put an 8 there and an 8 there. But it's not an 8. It's ugly. It's x plus delta x. So I put an x plus delta x there and an x plus delta x there. And I do it. All right, now it's FOIL time. FOIL time. Hopefully you've done enough of these that you're starting to get the pattern. X squared plus 2x delta x plus delta x squared. I got to do a cubed one in the future. They're ugly, but there's a pattern for that too. Minus 3x minus 3 delta x minus x squared plus 3x, because that minus times a minus makes a plus. So that was just a bunch of foiling. And what you should notice is the stuff at the back cancels. And all that's left should have delta x's on them. 2x delta x plus delta x squared minus 3 delta x. And you kill off 1 delta x from each piece. That gets killed, one of those gets killed, and that gets killed. So you're left with the limit as delta x goes to 0 of 2x plus delta x minus 3, which means my derivative at any place is 2x minus 3, because I plug a 0 in for that. All right, that's my equation that finds slope anywhere. I don't want slope just anywhere. I want slope at that point. Well, guess what? Here's my x part. Here's my y part of my point. Guess how I find the slope at that point? I plug this point in here. Now, what part do you plug in? I only see an x. Well then, don't use the y part, just use the x. So I'm really going to plug in. I'm going to say, what's the f prime of 2 means slope when x equals 2 is literally to just plug in 2 times 2 minus 3, which is 4 minus 3, aka slope of 1. So that line has a slope of 1 and a point of 2, negative 2. So here's your equation of tangent line. Remember how early in the year we did this thing? Point slope form of a line? Well, guess what? Y minus the y1, I'm going to do the point, I'm going to rewrite it down here. Y minus the y1 means y plus 2, because that's my part, equals slope times x minus x1. And then if I feel like it, I could, I'll distribute that. Distributing 1 doesn't do much. Subtract 2 from both sides. That's the equation of the tangent line. Technically, that's the equation of tangent line too. But I like this. Does it look like it's pretty much that equation? Maybe if I drew it like this. There, that would be perfect. The equation of that tangent line has a slope of 1 and hits at negative 4. Ta-da! Let's take it a step further. All right, let's try this again, but with one I haven't done in notes for you, and that is a radical one. Same type of problem. We are finding the equation of a tangent line on this line. Remember what that looks like. If I had a graphing calculator, square roots always look like shark fins. This one's been shifted 1 to the right. So it kind of looks like this. And at the point 5, 2, you got this, this kind of line looking like our tangent line is going to be sort of like that. All right, so either way you slice it, if you ask me to find a tangent line, I still need slope. I have a point. And if I need slope, guess what I need? Limit delta x goes to 0. F of x plus delta x minus f of x over delta x. All right, it's plugging in time. This is the first time we've done a radical one in a while. It was on your limits test, so it's not totally unfamiliar. You just didn't know you were doing it. You were training the whole time for this moment. All right, so first things first, I'm going to do that part, which means to plug in an x plus delta x right there. So you're going to do x plus delta x minus 1. And then that was easy. Minus f of x, which means I just copy this down, over delta x. Easy plug-in, right? Hopefully you got this. There's that part. There's that part. There's a minus sign between them and delta x on the bottom. So you get to a problem like this. We've done these before. If you have radicals and you need to kill them, you gotta multiply by the conjugate. I guess I did skip the step. If I plug in a 0, you get 0 over 0. Okay. So multiply by the conjugate, which is basically this thing with a plus between them. Okay, and whatever you do at the bottom, you got to do the top. So you just keep this exactly as it was, but there's a plus between them. Don't change what's inside the radicals. Okay, the conjugate is that. Now, what happens when you do that? We've said it in class before. When you multiply two conjugates together and you FOIL, remember, it's first times first. What do you get when you get first times first? Well, it just kills the radical sign. So you get x plus delta x minus 1. And then I said, don't even worry about outer and inner because one of them is these two with a positive. The other one is these two with a negative, so they kill each other every time. That's why we pick the conjugate. So really, all I have to do is do last times last, which is a radical x minus 1 and a radical x minus 1, but be careful because there is a minus on one of them and a plus on the other. So you have minus the answer. And once again, if you make a rookie mistake, people do, and that's to forget the parentheses, that it's minus x minus 1. If you didn't do this step, stuff wouldn't cancel. Oops, the bottom's not that nice. The bottom's this times this ugly thing. I was trying to make the problem really nice. I was like, they're not usually this pretty. Okay, that's better. The bottom's ugly, but just leave it like that. I'm hoping something on top cancels. Like I said, the only way stuff on top will cancel is if you remember the parentheses, because when you distribute this, the top becomes x plus delta x minus 1 minus x plus 1. All right, whew, okay. Now, I said stuff cancels. Let's check. Plus 1, minus 1, dead. Minus x, plus x, dead. What comes out? The limit as delta x goes to 0 of delta x on top, and on the bottom, delta x times radical x plus delta x plus radical x minus 1. And then stuff cancels. Woo! And finally, remember, your answer is not this because it's still on the bottom. So make sure you don't be a rookie. Don't be a rookie. Make sure you do 1 over this thing before you put in 0 for delta x. Now I can put a 0 in for delta x. Whoop. And you'll have 1 over that plus that. Well, if it's the same thing, you know, if I had y plus y, I would get 2y. Well, if I have one of these plus another one of these, I just have 2 of them. Right? Or if you had x plus x, you'd have 2x. If I had g plus g, I'd have 2g. If I have radical x minus 1 plus radical x minus 1, now I have 2 of them. That is your equation for slope at any point. So if my original equation was f of x, this guy equals f prime of x, which means it stands for the slope at any point. Well, I don't care about slope at any point. I care about slope at that point. So I need slope at 5, 2. So all I got to do is do f prime of 5. Remember, there's no y spot to plug in. So when I'm using this equation, I have nowhere to put the 2. I'm really just plugging a 5 in right there. Okay, so 1 over 2 times radical 5 minus 1. Oh, that's going to be nice, right? 1 over 2 times radical 4, which is 1 over 2 times 2, which is 1/4. So I have a slope of 1/4 and a point of 5, 2. So I can write the tangent line. It's y minus the y part equals m times x minus the x part. Now technically that's an answer. If you wanted to change it into slope-intercept form, I don't think it asked me to, but I can. It's not really hard. 1/4 x, and I need negative 5/4 plus 2, which would be, what, 3/4? I think so. Awesome. So that is the goodness, and hope you you grasped it. It's just one step further of using your answer and plugging a point in to find a slope. Using a slope and a point to write the equation of line. Okay, awesome. I will see you guys later. We'll summarize this the next time I see you in person.